Then welcome everyone to the AI Visualizer webinar. My name is Zsolt Oncsák and I will be your host today. And here are with me in the Graphisoft studio, Illés Papp, product manager, and we can thank him a lot about making this progressive tool available for public, and Jenő Barta, designer, who is the inventor or the creative mind behind the project. Taking a quick look at the agenda, Illés and Jenő will present you the concept of the tool, the benefits, and possibly some background story. And then you will see a very exciting live demonstration accompanied by a sort of tricks and tips or best practices session on how to use the AI visualizer. Please make sure to stay until the end, because after the demo, we will present you with a new community challenge, which brings not only a ton of fun, but also some valuable prizes. So with that, let me hand over the mic and the screen sharing to Illés and Jenő. The floor is yours.
Thank you. One moment. Okay. Hopefully you can see us, hear us, and see our screen.
Yeah. So let me just quickly jumpstart and quickly cover what is the Archicad AI Visualizer and what is it not. AI Visualizer is a Stable Diffusion powered visualizer, and we intentionally not saying it's a renderer because it is not a renderer. It is a visualization tool that helps you get inspired with very realistic results. But as you will see, and as we will describe, it will always help you developing new ideas, get inspired, and have some additional thoughts or options for the same concept that you provided with. So talking about that, I also would like to talk about the concept behind the AI Visualizer, because it is about the boosting your creativity in a way that it gets you inspired. And even if you would like to use it for visualization for clients, that's also possible, because in this very early stage with this, which this tool supports very well, you will be able to generate quite a few iterations of that concept that you have, which we will show you how to do that if you are not familiar with that yet. But we also will show you tips and tricks of how to use the best way possible. So you just provide the context, you provide the concept, and then it will provide you an idea of what is possible with that concept. And then based on that result, you can either further develop the concept, or you can also use it for client communications. You don't really have to model those details, because imagine what you would have to do without that. You would have to model details, render, perhaps even outsource rendering. But with this tool, which is integrated in the Archicad workflow, it becomes very easy and very smooth to be able to do such a thing. Anything to add?
Yeah, maybe just that also it's based on the concept that these ideas came from a really simple models, so mass models, basically just cubes and easy and simple shapes in your Archicad model.
Yep.
So yeah.
And before we go on and we actually show how this works, let me just quickly cover the workflow, because now we will start the generation, but let me just quickly cover how the workflow works. It's very simple. Just as we mentioned, you have your shapes, which can be modeled with any of the tools of Archicad. It can be even more detailed than what we show here, but as you will see, it works very well with very basic, simple concepts as well. You provide a sort of context, which is in a way of form of text provided, a description to say, and also some other settings. We will cover those too. And that will lead into a first iteration of an AI-generated image, which you can decide to keep, even lock the result. We'll also show you some tricks about locking the result and its counterpart, which we will reveal soon. And then you can just go ahead and keep it refined and go to find the final form of the idea that you wanted to explore. So I think now, before we go on and show how it works, I think the next slide is also very important, because installation is obviously a crucial part of being able to use it. Now, installation, we don't go into the details of the installation now, because we have a good description to be able to follow that and install this add-on on your computer, which you can find here on the website. But also you will be able to find the hardware requirements, the system requirements. It's very important that you may be able to install this add-on on a computer which is not enough to run AI Visualizer. In that case, the installation will very likely go through, but you won't be able to use it. So make sure that you use this AI Visualizer on a computer with enough RAM and VRAM, which is described in the description. If you get stuck or you find yourself lost in the process, don't worry. We have a community covering you. There's quite a discussion about these and other topics, so you will be able to find answers. And obviously, you can also ask your questions. And another thing that I wanted to highlight, because based on the feedbacks, we can see that this is important to talk about. Just as you will see in our demonstration, when you run the AI Visualizer, it is important that you keep the prompt. In this case, we are working on Windows now, so it's called command prompt. You need to keep it running. You shouldn't close it with the X, because that means that you close the server. So in that case, AI Visualizer won't work. So when you actually start the engine, there's a dedicated button for that. In that case, the command prompt, or in case of a Mac, a so-called terminal will come up, and then you need to keep it running. You shouldn't close it. That's important to be able to work with.
Yeah, and you shouldn't need to keep it on the screen.
Yeah,
So
you don't.
You can just put down on the tray, but you should not close it. So
Yeah.
that's need to that means that the engine is actually running.
Yeah, so I think now we can go and create the first generation.
Yeah.
And then we can talk about what is the input for AI Visualizer and how that works. So now we are generating an image, and just for the sake of understanding what happens in the background, we opened the command prompt. You don't need to keep it running in front of you. We just visualize it. That actually you can see a progress bar there, but even without having this on screen, it works. You will just see the throttle, going around and around in the screen, and based on your computer's powers and its ability, it will take shorter or longer time to generate an image and then visualize it on screen. How does this happen? So once you have the model, which we had in the background, and when you click on generate, the AI Visualizer takes this as a snapshot that was visible before the image was generated here. So it takes the snapshot and it uses it as an image. And it's very important that now we're talking about an image. We are not talking about a model. So it won't be a model that AI Visualizer receives. It receives an image of the content that you have, which comes being an important thing, because you need to show the depth and the shape of your model. And I think you have a good slide to show us what we're exactly talking about when we talk about that you need to show depth and shape.
In tips and tricks, we cover that.
Yes. So that will come later, but one of the sources is the image. So that's the first prompt, an image prompt.
Yeah.
The other prompt that we have is the text prompt, the contextual prompt. And there are 5 things that I just would like to highlight. So that's the thing we're talking about. And there's 5 things that you need to keep focusing on when you provide a description of what you would like to see the AI should generate for you. Visual style, architectural style, building type, materials, and environment. Not necessarily in the specific order. We will talk about the order later. It will just provide a so-called importance of the order will provide a sort of importance. But other than that, some of these are optional, so you don't need to describe the visual style. As you can see, the left-hand side and right-hand side, we have the same model with different prompts. The first one is missing the visual style. It has only architectural style, building type, and the environment described. Nothing about materialism, nothing about the visual style. Yet it provides a realistic result, which we like. On the right-hand side, we extended this prompt with visual style and with materials as well. But these are, even if you keep the prompt empty, it will generate a result for you.
Yes,
but,
absolutely.
Yeah, but you should provide these at least. I don't know. Perhaps you have something to add.
No, we're going to talk about it a bit more deeper later. Yeah. But yes, our default visual style is rendering, so it's a realistic style. And if you add something, it will generate upon that. So, for example, realistic pencil drawing.
Yeah. So those are already two inputs for the AI Visualizer that you should drive in a way we described. One is show the depth and the 3D-ness of your content, which we will cover in the tips and tricks, more details. The other one is the description of your model, and then the description should contain at least those most important characteristics that is described in the architectural style and the building type, and the rest is actually optional. So if we move on to the next slide.
One moment.
We have some. We covered the image and the text prompt, and then let's move on to the next one, because when we talk about the shape fidelity, and those are, let's just go back to the dialogue a little bit. So we will show what happens with the dialogue. Can you show the dialogue?
Yeah,
please,
sure.
for a short while. So we have, as you can see, we have shape fidelity, image size, advanced properties, and then at the end we will talk about also the log results.
Yes.
So shape fidelity. Shape fidelity is basically a reverse creativity, because if you would like to keep the shape and stick to the shape, then you provide less room for creativity for AI. It will always add something to the model, but in that case, if you increase the shape fidelity to very high, it will try to keep the shape the best it can, but which is the right-hand side image. And on the left-hand side case, you can see that it is dreaming up results, adding to the shape. Basically, we can recognize there's the shape, but for example, there's no diamond features at the left-hand side, right?
Yes.
So, and the rest is coming from the description. So that's how it works. And why is it we cannot set it to, I don't know, lower than 0? It's because it has no meaning, right? So
yeah, actually yes. So here you can see 0, but in the mind of an AI as a parameter, it won't be 0. Come on, here. Yeah, so it won't be 0 actually, because it doesn't make sense,
yep.
Because we're working with images or models, and actually as a just background info, you can trick the system by not using any model on your screen. So you can generate something pretty new, or you just tell the AI that you don't have a model, so don't use a model if you want. There's AI Visualizer become just a simple image generator.
So how does that especially work? So in that case, I won't show anything in 3D, right? So I wouldn't have anything in Archicad 3D.
Yeah.
I just keep it empty, and then I just provide the rest of the prompts, right?
Yes. And also I want to add that the 100% shape fidelity is not gonna keep every of your features. So visual AIs, foundation models, and generative AIs are not rendering engines. So they are not good at being creative and keeping every detail of your model at the same time. So this is why we say it's an inspirational tool, not rendering engine, because AI can't do that right now, but maybe later we'll do in the future.
Yeah, and I think the next topic is also very important, because when you select the image size, it's not only about the pixel by pixel size. And I think you have some interesting information about that, because it is in connection with how the AI was trained and what sort of source was used, right?
Yeah, so when it's come to image size, and it's a natural thing to think that resolution is just about it's just about resolution,
yeah.
like how many pixels in an image.
Yeah.
So basically a smaller resolution and a bigger resolution is the same, but with less details and a smaller resolution. But when it's come to AI, it doesn't work like that. So these two images, as you can see, are not the same. They are generated with exactly the same setup, but on a different resolution. And the fact or the reason why the 800 to 600 is different than the higher resolution is that when it's come to AI, the resolution works a little bit different. So AI is trained on a certain resolution. What we use, SDXL, is trained on 2024 to 1024 and the landscape and the portrait version of that. And actually, this is why we recommend to use these resolutions, because that's the AI's natural habitat of resolution. Like, this is what we trained on, and this is what the AI good at. 800 to 600 is okay, but you're going to get less detailed, less quality results. It's not just about resolution, it's about quality and details.
So basically, if we are rendering, generating the image closer to the size that you described, which is 1024 by 1024, 24. In that case, it will be perhaps crisper with more details, so it will be more realistic in that sense, right?
Yes, as the two images show.
Yeah. Obviously, to kind of like have a little bit more computing power, you can also go with the lower resolution, because there's also this difference between the image size, that the larger size of image generation takes longer than the small size image generation.
Yeah, definitely, absolutely.
Yeah, so in this sense, it's also affecting the performance. And iteration is also something that affects performance, because if you have higher iteration, it takes longer to generate. But what exactly happens here? Because here, again, there's an interesting thing. If you lower the slider, it's never becoming 0. And there's a reason behind that. We are actually working now with the low iteration, right?
Yeah. We are working with 20. That's the minimum. What we thought it's the minimum to get fine results.
Yeah.
And
why are we working with a low iteration, and what would be better if we would use a higher iteration number?
Yeah, it's actually when it's come to AI, pretty hard to describe, but actually you give more space to the AI to work and detail your prompts and what you want from it. So in this image, like we give it like a modern house with a city in the background, and as you can see, the different details of the same parameters, same image or same building concept is just detailed. More lights, more detailed lights, and more detailed building parts, and the background, the environment is even more detailed and more quality, I guess. But as you said, or talk about performance. Actually, to a 20 iteration to 50 is like 2.5 times more time consuming.
Yeah, and also if we would be able to see how this iteration steps progress, we would see that the very first iteration is very blurry, very just colors, and then from that it iterates to a more crisp and detailed result. So that's why that's how the number of iterations are important in that sense. And now you are actually generating another image with the same prompt, with the same other settings are all the same, resolution is the same, but with a higher number of iteration, right?
Yeah, and we can check out what we have. And actually, I locked the result, and this is not our next one.
Anyway, we will talk about that too.
But we talk about it too.
but while it's generating, let's also cover the so-called prompt strength, because that is actually sort of a counterpart of the other thing that we talked about, which was the shape fidelity. But shape fidelity is in connection with the image part of the input, and the prompt strength is in connection with the contextual text input, the prompt. So the prompt strength actually tells AI. So now we have a new iteration of the same. It took a little longer. I didn't measure how long it took, but
it took like 50 to 60 seconds. Yeah. And the other one is took like 30 to 40.
Yeah. Like, so the difference is measurable. Yeah.
Yeah, absolutely.
So I really like the result. So it's nice already, but as we can already see that 30 iterations is just fine.
Yeah.
For us,
and also fun.
We don't need to max it out. And it also has, and many of these settings also have effect on the RAM or the VRAM. As it depends on what sort of setup you have. But for example, in case of our system, which is a Windows computer with a dedicated card, in that case, the VRAM is intensely used during the process. So I was talking about the prompt strength and how it defines the result. At the left-hand side, we can see something that is a modern office building with a city in the background. And the right-hand side, we also see the same thing with the same input. The difference is the low and the high prompt strength. And in case of the right-hand side, we can see that the city in the background is more definitive, right?
Yeah.
So at the left-hand side, it was kind of a loose way of handling the city in the background, because there's maybe we are in the suburbs. But
suburb, that's better. Yeah, and we say it like secondary creativity slider. So it's not accidentally putting the advanced parameter side, because we recommend this to just experiment with it, because it could be a bit abstract. Why to weaken your prompt strength? You want your prompt to work. This actually advanced parameters are for like you lock your result, like you want to just iterate on this one, what you already like. And prompt strength can give a bit more creativity to the AI to work with. Like you tell them, if you lower this parameter here, tell the AI that you can derive from, so the AI could derive from your prompt a bit, like on this example, it's a pretty low number, but it just gives more flexibility, and like you can just leave out the buildings or such. So it's for experimentation. As a secondary creativity slider.
Absolutely, and I think now comes the part that you wanted to talk about, which is the log result. So let me have you here.
Thank you. Okay, so a log result is an interesting thing, and not particularly hard, but sometimes a bit confusing to talk about. It actually locks the overall feel and, let's say, style and vibe of your latest result. So as you can see with this result, we have white walls and wooden surfaces and afternoon or an evening scene. And if I log the result and do another generation, it basically the AI try to keep that way. So every generation is brand new if there is no log result. So you get something brand new. But if your log result, you tell the AI that you want to keep this style of generation. So if you do something like that and try to check the back of the building, it won't be the same building. The AI just try to keep your white walls and wooden structures and afternoon scene, but you get a way different building. So.
And I think it's an important thing is that because of what AI sees, and we will cover that just in the next step. We are arriving to the tips and tricks now. Because of what and how AI sees in the 3D or from the 3D, which one is better, the result won't be the same image of the image of the same building from the perspective of the AI. And also it's important to say that log result will try to keep the shape, but it won't keep the same exact shape also, right?
Yeah,
but it will keep the characteristics, the style, and the theme, materialism, and so on.
Yeah, so in the generative AI, the visual generative AIs, we have a term called seed, and every generation has a different seed. And with this lock result, we can fix the seed, so we generate from the same seed over and over. And actually, what we have as an example here is 2 different resolution, and it happened like I generated this one. It's a nice container building. It's a black container building. I really like that. And then I locked the result and generated a higher resolution from that. And it's actually not the same building, but it kept the original idea that it's a black container building with these really moody backgrounds and such. And maybe the grass style. So lock result is like that. So log the overall feel style of your latest result. Your next generation won't be the same building, but will be similar.
Yeah, and we have sort of a sister of this feature, which we will cover in the Diffcentrics, and that's
the
also
cheat code what we
yeah. So we already talked about how AI sees the world, which we provide, this virtual world, the model itself, and we covered that it won't see the model. It will see what exactly? So we can show now, I think.
Yeah. So when it's come to what the AI actually sees from your model is imaging like this. So let me put it this way, and also let's start the generation like that without the lock result. So if you show this image to a person who doesn't know Archicad and building modeling or just modeling, what he or she will see? They see 2 rectangles basically, and as we said, we take a snapshot from the 3D model you have, and that we send out to the AI. What you usually gonna get with these kind of frontals with 2 rectangles is the top-down view with a interesting twist sometimes. So the basic rule here is you should show the AI your form from like a bird's eye view, like this one. As you can see, it's generated with a lock result. So we log the result, and we actually get back these wooden surfaces and you know, these really nice windows. But the AI was actually able to see our form here, and it turned out really weird.
It's a very good
very
representation of that.
Because the AI thought that this one is like kind of a rectangular or something like a garden, and this is just a box. So the thing you need to do is like show off your form, like this one, to show the perspective and the 3D characteristics of your model. And the next thing is like is exactly the same, but with curves. So when it comes to like curved shapes, for example, like this one here, you should really focus on showing those curves to the AI. Let's generate a good result, because they're not going to understand what your curves. You have curves, you generate a frontal, it just will be a rectangle for it.
So basically, the suggestion here that we're recommending is to show perspective, show depth of your model through the image that you will provide eventually to the AI. So it can understand the connection between shapes, what they are exactly, and provide it with your description, because that's a key point here, that you need to describe what I'm going to see if I'm imagining this being a building. That too will end up having a good result or a not very good result. And so basically frontal views, top-down views won't work well. You can try, but it won't necessarily end up with the result that you want.
Also, it's a pretty trippy result. But AI usually, not particularly usually, but sometimes generate. But actually, it detected our form that we have a curve here, and so. And also what I do here is that I try to fit my model, or I try to feel the image what I show to the AI. So I'm not doing like this. So because this is going to generate something in the middle. So try to feel the screen and generate like that. And So something like this, and also show the AI your model characteristics.
Yes.
Yeah, and this is about scale. Yeah, so let's talk about a little bit about scale.
Yeah, and I think it's because the simple thing that we just described several times, that we don't provide the model, we provide the image. So based on the image is measured in pixels, so there's no size in it. We can, as human beings, understand or imagine the size sometimes, because if I'm shown two boxes, I'm also in the dark. Okay, what's the size of those two boxes? So AI won't understand the size of the boxes other than you describe the size. So you provide this is a, I don't know, a dwelling, or it's an office building, or something like that. That sets the size of the final result. Just as in this case, the left hand side was provided with something house, and the right hand side was like something office, right?
Yeah, actually, if you we are working in an architectural software, engineering software here, so it's natural to think that our dimensions, what we put in the model, is actually meaningful. But when it's come to AI visualization, AI visualizer, it doesn't matter at all. So it could be 2 centimeters or 2 meters. The AI only will see an image. So the first thing what you can do to affect the scale and tell the AI what scale you have is to tell that it's a house or an office building or a skyscraper, even bigger, or it's just a cottage, or what is it? And as you can see in these two images, it's a smaller building and it's a bigger building because it's an office building. And also you can do to add some building features. For example, let's go back to this one to explain. You go here. So you have some kind of a pavement here, a door, some kind of a window, a porch, and also a door. And actually, the AI is really good at detecting these. You see, we have a door here, but also in office building we have a door here, but it's a big aula door. Yes, a big one. So you can help it as well.
Yeah.
So that's scale for you. The main thing to take home from here is that your Archicad dimensions won't be understood by the AI. You have to tell them.
That's right. That's right. So actually, two things: description and modeling. Takes an effect in scaling, understanding the scale of the building.
Absolutely.
And I think we came to another interesting thing is how we can affect materials on surfaces of our models in the visualization with the AI visualizer.
Yeah.
So one thing is that, as you can see in this example that we have here, is that obviously you can provide a hint, or even more, being more specific, like a direction to the AI visualizer, that okay, I applied brick here. So, and even I can make it stronger by highlighting in my description that this should be brick, containing brick and concrete surfaces and so on.
Yeah, that's the idea.
So in that case, I'm actually like underlining that whatever I used on the image should be kept as seen, right?
Absolutely. So controversial topic. Materials actually can work. So as you can see, it's no specific prompting. It just detected that it's some kind of a grid and wood, and no concrete here, what I told with my
image.
Yeah, with my image to have. But when you add some prompts like wooden, brick, concrete, it can affect the final results. So we recommend experiment with it and use it to your advantage. So yeah, it's not perfect, but actually it can work. So yeah, experiment with it.
And may I add two other things, because together with this, with materialism and together with the modeling, there's two other things that you can actually control the surrounding as well, right? So if you, just as in case of the pavement, that's already part of the surrounding. So if we place features of the surrounding, that also helps the understanding what's the surrounding. And also if we add materials to the surfaces, like the pavement is concrete, but perhaps next to that there are two shapes with green material. So then in that case, the AI visualizer will understand that, okay, that's very likely some sort of grass surface or something like that.
Yeah, right? and it actually can detect trees and such. So you can experiment with that, and it can be used really nicely. Okay, this is a short one. Like the order of the words in the prompt field is actually matter, but don't sweat it. So what do you mean by what I mean by that? So look at this beautiful pencil drawing, realistic pencil drawing of modern office building with metal surface and city in the background. So this is exactly how we recommend to build up your prompts based on what you tell you about the prompting. But if you jumble all the words around or all the sentences around, like city in the background, modern, yada, 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 it's actually, you get kind of the same. This is what we recommend, but don't sweat it. It's not really that important. We pre-prompted that the way to work in almost all the scenarios.
Yeah.
Keep this in mind that this is a recommended order, but this one can work as well. So
yes, and about the result, that you can also exclude parts from your visual, right, by using negative prompts.
Yeah.
But in this case, you don't have to learn negative prompting. You just simply say that you don't want to see something, right?
Yeah. Actually, it was a nice transition because that's what we're talking about. Is negative prompting actually can work. So in AI, visual AIs, generative AIs, usually we have a negative prompt field. We didn't included that. However, you can use negative or not statements in the prompting to affect the results. For example, we generated a winter scene and the snow. And when we actually add that not a winter scene and not a snow, we get almost the same building, but without the snow. Yeah. So if you have a result, for example, like this, and you don't like something, do not be scared to add some not or negative statements. Use it to your advantage, and it can actually work.
Yes, and I think the next part is when we talk about how you can be creative is also a very interesting part, because here you used quite a few interesting styles of how you can visualize the results. So the default, let's say, setting of AI Visualizer is to provide photo-like results, right?
Yeah, like default styles are rendering.
Yeah. Kind of like renders, yeah.
And what we usually recommend is pencil drawing and oil painting and this artistic style. But here we have a funny example like anime style. And as you can see, the sky and the trees are really nicely incorporated from animes. And actually, the AI incorporated the building styles,
colors,
and colors. So when you want to get inspired and get ideas, you can get it many places, like real buildings, books, collections from the nature, and AI Visualizers aims to be one of the inspirational sources. And when it's come to inspiration, be creative. So don't be scared to add really wild parts to your prompting, and actually get inspired by that, because you can get something really special from it.
Correct. And let me add one more thought to how you can drive the style of the final result. When you are describing something, your words have colors and style. So they actually describe. So when you told like it should be anime style, that comes with a certain set of colors, saturation, and things like that. So those will also affect the results. So just if you try to imagine what your word will describe in means of colors, style, and saturation, that's exactly what will happen with the final result.
Yes.
So that's another tip how you can use it if you imagine the colors and style and visual style of associated with the words that you use.
Yes, absolutely. So words and style have a really strong connection.
That's right. Yeah.
Yeah, and lastly, we want to talk about that cheat code we just mentioned not that long ago, the loopback function. Yeah, we call it in a funny way cheat code because it's not on the interface, but also it's on the interface. Like if you shift click the generate button, you can activate this loopback function. And when it's come to like generating, just simply generating and pushing the generate button, not using the loopback function, AI Visualizer will take a snapshot from your model and use it as a base image. It's a bit a weird result, but we can work with that. And when you shift click on generate, like use the loopback function, AI Visualizer won't use the model or the snapshot of your model. It will use your last result. For example, sorry for the jumping around. For example, using this as the base of your generation.
So I could even remove the model from now from the background.
Yes.
It won't affect the result, only the image generated previously.
Yeah, and you can fiddle around with the different parameters. For example, I put down shape fidelity or just pull a bit down, and let's just keep the modern house to get back to the default style, and let's shift click.
So now you shift clicked.
Yeah, I pushing shift.
Yeah.
And generating. So actually, remember this image because everything goes well, it will be our base for the next generation. So we will probably keep this tree and all the characteristics, but generate a different image. Yeah, it's a bit low shape fidelity, so maybe it adds some more creativity, but let's see. But we have some prepared examples for here, but we go back to Archicad soon. Like I generated this really interesting office building, and I use the lookback function, but with a different prompt, a realistic pencil drawing of a modern office building. So I want the realistic pencil drawing, and I actually get that. It's not the same, but it's based on this one. So you can use that to change a style from render-like result. And also, if you generate something artistic, you can use it to delete the style part, like from your prompt, use the loopback function, so shift-click generate, and actually get a realistic result from that. So it's kind of the same, but on a different style.
So I think this is the biggest difference between the lock result and the loopback function.
Yeah.
Just as we can see, loopback function keeps more of the original, the generated content, because it actually uses the generated content as a source.
Yes.
So that's the difference. In the first case, when we only log the result, we log the result, but in the sense of keeping the style and colors and things like that. But in case of the loopback function, we actually use the result generated previously as to generate a new iteration of that, right?
Yeah, absolutely. That described really nicely. So the AI will generate based upon your last result, and remember the shift click.
Yes.
And I think that's it. So
thank you. So that's what we prepared with, and we hope that we could show you good and interesting ideas, concepts, and tips and tricks of how to use the AI Visualizer. And we are here to answer your questions. So I think we can give back the word to Zsolt.
Yes. Let me jump to our next topic, which is our last topic, the AI Visualizer Challenge. So I'd really like to encourage everyone to participate in this challenge, and let me share some additional information about it. So how to participate? This challenge is hosted on our community website, and the way to participate is to upload 3 images directly to your entry. So you go to the community page, you can very easily enter the contest, and you basically have to provide a design mood with some of our provided textures that you will find again under the challenge, within the challenge's website, and a perspective view of a mass model and the AI Visualizer result based on these inputs. And the most captivating entries will win a €400 Graphisoft Learn voucher that you can apply on the Graphisoft Learn portal, learn.graphisoft.com, where you can find many useful Graphisoft trainings. And you will also receive a champion community badge and an exclusive roundtable with Illés Papp and Jenő Barta, whom with you can set up a meeting and talk freely about the AI Visualizer more in depth. So the submissions will be open until March the 31. And again, I encourage everyone who is up for the challenge to take part, make some buzz around this new tool, and try to get the most out of it. So thank you again for joining us today, and please check the Graphisoft community website. And again, you will find the recording of this webinar again on the community website. So see you, everyone.
Thank you.
Thank you very much. Bye.
Thank you very much. Bye-bye.